Anti-deriving is the opposite of deriving. We're going to try and take our natural thinking and go backwards, which is going to be really, really difficult. It's really difficult to try and do backwards of what your brain wants to do. We're so accustomed to deriving. So we're going to do opposite of that today. So a function, capital F, is called an antiderivative. Okay, so if I took, what that means is if I took the antiderivative of f, function f, it's equal to big F. So
it's like f prime versus f.
Right. So instead of saying, so say my original function, so if I took actually the derivative of my antiderivative, it gives me my original function.
So like if you yell at.
So right, so now it's like I'm giving you the slope, and you're telling me what would the function had to be. If I gave you the equation for the slope, what was the original function? No, if you take the derivative of the antiderivative, you'd have to look at different applications. So if you took, for example, acceleration, if I had an acceleration formula, guys, the antiderivative of acceleration is velocity. The antiderivative of velocity is distance. Okay, so we're going the opposite direction. So this is the derivative of what function f would result in our function. The derivative of some function, big F, would result in the function little f. Question mark, I guess.
So the derivative of big F is little f. The derivative of little f is f prime.
Yes.
Oh, so it's just like a second derivative of big F is f prime.
Yes.
The second antiderivative of f.
Okay, so basically we're going the opposite direction, okay? So for example, if our function is 4x minus 7, a possible antiderivative would have been 2x squared minus 7x, say, plus 3. I'm giving you a possible. Okay, the constant could change. If you had a function like 3x squared minus 5x to the 4. 3x squared, derivative of what is 3x squared? X cubed. Yeah, derivative of x cubed is 3x squared. What's the derivative? What derivative of what would be 5x to the 4? Minus x to the 5th. Say plus some constant. Let's go 2. Plus c. We're going to write just plus c in the future. Because there could have been some some constant. When we derive this, there's multiple constants. It will give you the same slope equation.
Wait. So we're never going to know what the plus is.
Okay. Unless we have a point, let's just put plus c, then...
Well, how do we know it's... Well, I guess c.
Right. It could be 0. How about 8 cos 2x? Try to figure out what would you do, what would be... Oh. Okay, so think, if I derive what would it give me cos? Okay, so derivative of sine is cos, so it had to have been originally sine 2x. Now, if I just derive sine 2x, it would give me cos 2x times 2, the derivative of the inside. But we have 8 in front, so it had to be 4 sine 2x plus c. Backwards. Okay, now, this is a point in your life, or at least when you get to the next page, you're going to want to have that yellow formula sheet out. That thing is going to be your lifeline, because you probably don't have all your derivatives memorized, and therefore don't have your antiderivatives memorized. Okay, so let's say our function is equal to 3. So this is the same thing, right? The derivative of the antiderivative is our function. Is equal to 3. Y equals 3. Right, so that is the equation of our, that's basically their slope. Our slope is 3. Could the original equation look like? So this means that the original function, yeah, we're going to get to that after. We're using integrals. So this means the original function f, big F, must have a slope of 3. Okay, because that's the, so then it would have to be 3x plus c, y equals 3x, or the simplest version would be y equals 3x. However, we could also have y equals 3x plus what? Oh, I have 2 here, 12, or we could have 3x minus 8. I've already drawn them for you. Okay, all of these, would they give the same derivative? Yeah, they'd all have the derivative of 3. Okay, so when we do antiderivatives, we don't necessarily know what the constant was. The constant was canceled out when it was derived. And so we have to add that plus c. So in general, we would say y equals 3x plus c, some value c. All these functions have a derivative of 3 since they have the same slope for all values of x. They are called parallel functions. You can see why they would be. Parallel. Okay, that's... I know, that was funny. It's haunting me. Okay, so thus antiderivatives are not unique, but derivatives are. Okay, okay. So derivatives, when you find the derivative, there's only one answer. Okay, when you find an antiderivative, there's more than one possible solution because of that plus c. Okay, that's okay. I like the word unique, but you don't have to like it. Okay, so summary, if our big F, which is our antiderivative, so if big F is an antiderivative, of some function f, which means the derivative of our antiderivative would be that function, called the general antiderivative are, I know, hey? Sorry, are represented by the equation. Okay, let's see here. If f is an antiderivative, then all antiderivatives, what did I write? Oh, forgot that. Then of f, then comma all antiderivatives. I forgot this part here. Of f. Sorry, this was missed. No, it doesn't make sense otherwise. Okay. Where c is a constant. I don't know if you need to write that. So that's a general antiderivative. So general plus c, something called particular, we don't need the plus c. Because of the plus c, because if, exactly. No, but there's more than one possible solution. Okay? Okay, so particular antiderivatives, ignore the plus c. Find an antiderivative called integration. So integration and antiderivatives are one and the same. It's the reverse of deriving or differentiation. Okay, so let's get to some fun.
Is this a fun unit?
I like it.
Besides the trick.
It's kind of like derivatives where you're just,
It's kind of like
but it's the opposite. Yeah, it really is.
What
So,
is the antiderivative of sine?
yes, that makes sense. Okay, so the question is, derivative of what would give you sine?
Negative cos.
Negative cos. Okay, give you a moment to think.
Fine.
Okay, so does anyone remember derivative of what is secant squared x?
10.
10.
Yes.
Okay, now this is where it gets trickier because I forget these ones.
That is
That's where,
That's secant.
if you have your yellow
That'd be negative
formula sheet, these are all, they're written as integrals right now, but same idea. So it's an antiderivative. But
So negative
it's,
cos.
I have to explain to you, it's in terms of area under the curve, okay? So we'll get to that lesson, but just know for now, when you take the antiderivative, you're basically, it's like finding the integral. Oh yeah, that's gonna be funny. That's pretty, you have to use something called substitution by parts, and I don't know if we'll get that far.
Anti-implicit differentiation.
You have to use something called substitution by parts. It's pretty tough. All right, so here they are. So if you wanted to look up cosecant times cotan, it equals to what? Negative cosecant x. Okay, antiderivative of secant, tan. Is secant? Thanks. And last, cosecant squared, negative cotan. Sweet. Okay, so let's look at powers. What would be the antiderivative of x to the negative 3? Okay, so close. You have to think about
1/4 times
Negative 1/3.
1/4 x, 1/2 x to the negative 2.
Okay, so let's think about it this way. I'll help you. It's not a quarter.
No, it's 1.
When we derived, what did we do with our power? Add or subtract 1? Subtract 1. So this time we're going to add 1. So we know our power here would have had to been negative 2, so it would be up to negative 1 over 2. Because if I derive this, the negative 2 times negative 1/2 would be 1.
Yeah, okay. Yep.
Okay, so first figure out your power. Okay, so you're adding 1. Okay, and you also have to divide by 1 over that exponent, which of negative 2. Because when we did, guys, I need you to not talk right now. When we derived, we multiplied. So if we're anti-deriving, we're actually going to divide by that new constant to go backwards. So I'm going to give you a formula in a moment, but I want us to try and figure out derivative of what would give me this x to the negative 3. Okay, so let's try another one. Derivative of what is x to the negative 2? Okay, so let's double check. If I derive that, that would give me negative x, so we're close, minus 2. We want positive 1. What if it was a negative 1 in front? Let's try that. Derivative of this would give me negative 1 times 1 is 1. X. There we go. X to the negative 2. Good. Okay, x to the negative 1. If we add 1 to that, okay, that one, yeah, it's a little special. Derivative of what is 1 over x? We did this before. Yeah, we can't figure it out right now. We can't do. Because, yeah, it gives you 0, and we can't work with that. So this is where we have to use logs for this guy. But we're not going to do him. Can't do. It's not.
No, because then you
right? Derivative of 1. Yeah, so that we're stuck at this point. I believe the derivative of natural log of x is 1 over x, right?
What's the derivative of
Right?
e to the
So this
x?
would be natural log of x. But, right, because derivative of natural log of x is 1 over x. Correct? Correct?
Correct.
Am I not? Yeah, there it is.
Oh,
Yeah. So we can't use a power law. It's special and unique. You can't do with a power law. It's unique in that it's natural log of x.
So is the antiderivative of e to the x dx?
Yes. Okay, so how about x to the 0 or 1? What would be the antiderivative? Derivative, okay, let me rearrange this. Derivative of what is just 1? Derivative of x is 1. Okay, derivative of what is x? Well, let's first do our power. What would the power be? 1/2 x squared. Okay, because 2 times a half would give you the 1, and then we subtract 1 from our power. 1/3. Do you see there's a pattern here? There should be a pattern. The pattern is this. If you're wanting to take the antiderivative of x to the power of n, it would be 1 over n plus 1 times x to the power of n plus 1. And that is on your formula sheet. Okay, so basically our power rule was multiply by the coefficient and then subtract 1. So we're now dividing and adding 1. Okay, polynomial antiderivatives, so these are just, if you had a constant times a function, it would just be still the constant times the antiderivative, just like when we derive, like derivative of 2x was 2 times 1. Same idea when we antiderive. So you can just find the antiderivative of the f, and then times it by the constant. I should write f of x and g of x. Kind of looks funny. There you go. Big F, B, yeah, and find the antiderivative of both and still sum them. And same idea of subtraction. Very difficult dealing with chain rules. Yeah, we're only going to go so far with those because there are special rules we'd have to learn. It's called substitution by parts. As we see later, the symbol for finding the antiderivative is right there, which is called an integral. Thus, the integral formula on the formula sheets can be used for antiderivatives, so you see that. Okay, so let's try some examples. I excuse the double of the, I don't know if anyone noticed that yet. Oh, did I delete it? Yes! Love when that happens. Oh, mine says the. Oh, does yours say the? No, right?
No.
Okay.
When did you fix it?
Maybe last year.
Do you remember that there was a the?
Well, I probably like after lesson went up and changed it. Okay, we want to find the antiderivative. Okay, so so we have a constant in front here. So I'm going to take this one step at a time. So we're going to 2 times. Let's do the antiderivative of x cubed. 1 quarter, because we're adding 1 to our power, and so we have 1 quarter x to the 4. Plus, what's the antiderivative of 5? 5x plus c. Okay, so simplifying this, 2 times a quarter will give us a half x to the 4 plus 5x plus c. How are we so far? No? It's tough, right? It's so backwards. It's so backwards than what we're used to. Okay. Okay, f of x equals. So 3x, there's a constant in front, so take the constant and let's do the power law in the bracket. So antiderivative of x, half x squared. We're adding 1. Okay, so this is where we're going to grab our formula sheet.
The yellow one or the green one?
So this, the yellow one, the antiderivative of secant is, now there's something that's going to cause some problems. The 5x. So we know the antiderivative of secant squared is the tan of our inside. But we have to divide by the derivative of our inside instead of multiplying by the derivative of our inside. So I'm going to write 1/5. Okay, so this came from dividing by the derivative of the inside. If you lost yours, I have extras. Okay, does that make sense? If I had 1/5 tan 5x, and I ask you to derive that, that would be a 5th secant squared 5x times the derivative of the inside of the 5. So we had to get those, here there is no constant in front. So that's why we had to divide by 5 or multiply by a 5th. So this simplifies to, oops. Let's put this back. Do you know where to find it? Right down there. 3/2x squared plus 1/5 tan 5x plus c. Is it? I better make more. How are you? Are you okay? We're not hyperventilating yet.
No, this is good. I like this. It's actually like more
Okay, I might be hyperventilating. It is reversed, but it's so backwards to what your brain wants to do. So that can be tough. Okay.
Like, there gonna be like a lot of free questions in this next week.
There could be triggering, but it's just more the deriving stuff, not the evaluating. Okay, there's not the applications of integration. I don't know if we'll get to that far. That might make other than say acceleration type stuff. Okay. Well, the applications for antiderivatives are so awesome.
Like fun?
Yeah, they're so cool. They blow your mind.
Can we do one right now?
Because even when you get into university, so you can look at, say, the 4th dimension. It's like crazy. Okay. All right, so going on. Antiderivative of coast. Okay, can you try this one on your own? If you're all talking. Shh. What is this? Get it down.
Don't write notes. Never realize that there's an inverse relation between note writing and grades. In grade 10 in social, I wrote lots of notes. Didn't do very well. Grade 11.
Okay, you might want to. Shh, don't talk so much.
No,
Try.
Did so well.
Okay, change my root x to x to the 1/2. So we start with coast. Derivative of what is coast?
Why did you write it twice?
I just wanted to rewrite it because the 1/2.
And why did you write it? Why did you change the sign?
I don't know. Good eye. Okay, so antiderivative. Yeah, I didn't take the antiderivative yet. I just rewrote my function without a radical. That's all. Okay, so antiderivative of coast is sine. We agree? Okay, there's a constant in front, so it's just 4 sine x. So you can double check always by taking the derivative of what you just made, and it should be back to the original thing, which is nice. You can check your work. Alrighty. Derivative of sine is what? Cos, negative cos. So if you have a negative and then a negative cos, it's going to be plus. So 9 cos of 3x. Now what do we have to do with this? Sine is negative cos. Antiderivative. Okay, now Why did I divide by 3? Divide by the derivative of the inside. Instead of, because we're going opposite direction. Whew, that was fun. Okay, plus. This is another power. I'm going to separate the 6 from the power. So how, adding 1 to 1/2.
It's going to be 4x to the 3 over 2.
We'll get there. You're welcome to jump if you want. Okay, so if I add 1 to 1/2, that's 3 over 2. Okay, now, instead of writing 1 divided by 3 over 2, what could you write?
1 times 2 over 3.
Or just 2/3. Right? 1 over 3 over 2 is just 2/3. Which one? What? Okay, because of this formula. So if my n is 1/2, then n plus 1 is 3 over 2. So x is 3 over 2, 1 over 3 over 2. Well, that's pretty ugly. That's ugly, right? So just, we're going to multiply by the reciprocal. It's the same idea. Okay. All right, plus c. So we can simplify this. I know, it's the worst thing in the world because you'll forget about it all the time. Plus 3 cos 3x. And then this becomes, yes, Gregory, 4x to the 3 over 2 plus c. How could you check your answer? How could I check my work? Derive it. And what should I end up with? The original. Logical.
Wait, so you can, like, we could have been checking our answers with antiderivative this entire time.
I guess. Okay, what's the antiderivative of sine?
Negative cos.
Negative cos. Now, if I leave it like this, am I done?
You're going to divide by 3x minus 1.
Nope, divide by,
3.
why just 3?
The 1 is
We divide by the derivative of the inside.
divide by the derivative.
Yes. Okay, plus c. Or you could also write this as negative 1/3 cos of 3x minus 1 plus c. Right, if I derive this, right, just to check my work, negative 1/3, derivative of cos is negative sine, times the derivative of my inside. And that's how these 3's are going to cancel out. Let me derive. Yeah, they're kind of not comfortable at first, but you'll get used to them, I promise. Okay, antiderivative of cosecant squared. Tan. Now.
Negative cos. No. Negative cos.
Oh, thanks. Negative cotan. Okay, are we done?
No.
What do we have to do still?
Times by 1 over 3.
Times by 1 over 3, or divide by the derivative of your inside plus c. Okay. This looks worse than it is.
No, it looks fun. Let's do it. Yeah. You should let us do it.
This one actually, no, this looks way more cool.
Okay, I want you to try it.
Yeah. Do we accept product rate?
No.
No, let's just shoot.
Where do you think this x came from?
Probably got. Probably from the top. Yeah.
No.
Yeah.
Probably not. Yeah.
Okay, give.
It was factored out of the inside.
From, whoa, what was that? From deriving the inside. Is that what you said?
No.
Yeah, okay, I didn't think so. From derive that. So really, we don't have to, this guy is going to cancel out when we divide by the derivative of the inside. In the cases that I'm giving you, yes. I'm not going to give you really complex ones that were initially product rules. That's where you'd need substitution. Okay, so here, so you're just going to ignore this x because I recognize that actually wasn't really part of the original function. That was from the derivative of the inside. So power rule here, what are we going to do with the negative 2? What do we do with our powers? We antiderive. Instead of subtracting 1, we are adding 1. So this becomes negative 1, and then we also have to have negative 1 in here. No, not yet. You're ahead of me. Okay? You're ahead of me. Yes. Yes, it's a multiplication. I always a dot for multiplication. Okay? And then we have to divide by the derivative of the inside. What was the derivative of the inside? 2x. So this simplifies to, what happens with our x's? So a negative half x squared minus 1 to the negative 1 plus c. How can I check my answer? Derive. Negative 1 times negative a half, positive a half, subtract 1 from my power, and then times by the derivative of the inside is 2x, and that's how those 2's are going to cancel. So you can check your answer by deriving what you got. Ooh, don't race that guy. Good thing for undo, hey? I know. Sometimes we can make things right again. Okay, do you want to try this one on your own? I think you should.
Yeah, yes.
Give it a shot. It's not that bad. Shh, try it. Come on, Greg. I'm gonna start this. I'm gonna leave the constant outside. Now the power here, I'm gonna add 1. So if you add 1 to 3 over 2, it's equal to 5 over 2. So this will be a 2/5 in front. 3x minus 1 to the power of 5 over 2. Because 1 over 5 over 2 is 2/5. Times, or divide by the derivative of the inside. What's the derivative of the inside? 3. So I can times by a third or divide everything by 3. Because when you actually, if you want to take this new function and derive it, for them to cancel, because this 6 in here has a derivative of the inside of it. So in order to eliminate it, we have to divide by the derivative of the inside. Okay, so this is going to give us 6 divided by 3 is 2, so 4 over 5, 3x minus 1 to the 5 over 2 plus c. Now if you wanted to check your work, take the derivative of your antiderivative. 5 over 2 times 4 over 2 is just 2. Okay, so 6 times 2/5 times a third.
What'd you get a third?
Third is dividing by the derivative of the inside.
Dividing by the derivative of the inside.
Or times by 1/3.
No, don't say that.
We have, because when you originally derived it, so this is our derivative. We want our original function. Okay, so wait, before you argue, just relax.
No, I don't.
This is our derivative. We want the original function. So this 6 in here, part of it came from the derivative of the inside, the 3. So to eliminate that, we have to divide by the derivative of the inside. Right? In the past, we always multiply by the derivative of the inside. Since we're going backwards, we now have to divide by the derivative of the inside. Well, dividing by 3 is the same as multiplying by 3. So how?
What's the bottom?
So here I'm checking my work. I'm not done. So 5 over 2 times 4 over 5 is just 2. Subtract 1 is 3 over 2. That was, remember we divide by n plus 1. So if I divide by 1 over 5 over 2, the same as 2 over 5. Okay? And then times by 3, the derivative of the inside, the derivative of a constant is 0. So that's why it's 6. Okay, so guys, the assignment used to be 1 to 7. I have shortened it to be a lot shorter. Used to be 1 to 7 all. But now I made it to this. So I want you to know it's been shortened.
$50 so they can
Okay?
qualify.